All right, so I'll get started. So let me see. Yeah, I'd like to start switching gears a little bit and maybe going and looking at a little bit the projects. So I just posted in Slack a link for the projects repositories, so you can go and create them. So this is similar to the assignments. The only difference is that it's a group assignment. So coordinate within the group to have at least one person who accepts it, and then work with the others to make sure that you can get in the same repository. I think that once one person accepts it, the link stays open for the others to accept it. So let me know if you have trouble with that. In the past, I don't think that we had many with it, but I don't know exactly what are the mechanics of it. So with this said, I'd like to maybe show you, to give you a little bit of a tour of the project. So let me put this on screen. So you know what is what at least, and where you want to go and put your code and data. Yeah, this is no, this is not it. Okay. Okay. For whatever reason, it doesn't want to show me the right screen. So hopefully you have the Visual Studio Code on screen open with the project files available. So I'll go quickly through it so that you know what is what. So right here we have the README. So you should go and take a quick look at it because I'm going to ask that you update it with your team name, the team members that you want to list. You have already the format here for the first one. So for all the updates that you're going to do in here, I'd like to request that you do them in the same way that the example is shown, so that we have something consistent for all the groups to look at. So here in terms of artifacts, so this is what is going to be asked for the projects. First, to create a project proposal that you have basically done. So here there is a link that is not set, as you can see. So this is the markdown for the link. So you'll want to link this to the Google Sheet or presentation that you have created, so that we have it there for reference. The final presentation is going to be done in SOSI with Inkscape. So I'll show you this in a week probably. We'll do a lab on that. And the format is going to be Pechakucha, that is normally it's 20 slides, 20 seconds per slide. Here we're going to adapt so that we can hopefully have time to present it in person or remotely for those who are remote. Ideally, it should be presented by the group, meaning that everyone would have to say something about one of the slides. I'm asking for the transcript because the Pechakucha format is basically just pictures. So all you have to do is set up a slideshow with pictures, which is more or less already done. You just need to find the pictures that match what is it that you want to talk about. And so for you to have your ideas down and also for us to remember what you say during the presentation, I'd like that you write it down in the transcript. So it can be in the form of bullet points, or it's up to you if you want to put it in words. And when you present it, you can just go and read them. But this is mostly for us to, in case we want to go and quickly look something in the presentation because we need some information to make a judgment, then we have there one quick way to do it. Obviously, if we do it, we do actual presentations, then we're going to have a recording with Zoom. So yeah, I still need to organize that to see if it's going to be practical, given that we're doing this hybrid thing here. So I need to think about it. The paper is basically a standard research paper format. I'm going to ask that you do it in LaTeX. So a lot of the scientific publications are created in LaTeX. So we're going also to have a lab on that. So you know the basics. You won't have to install anything aside from creating an account on the system that is called Overlift that gives you access to that. And then from Overlift, you can also produce a PDF and then just put it there. The demo link here, I need to correct this because as you can see, yeah, so something went off in my, for some reason. Okay, here it is. So please correct it in your copy. This should be obviously another bullet point. So this is the link to the demo. What we did in the past is that we deployed it on a system that I provided, which is a Unix system. I don't know if we're going to do this year. I don't mind doing it if we do it we'll need to do it early so that you get a little bit accustomed to it. The alternative is that we do it after you finish your project. And what we'll do in that case is that we'll need to have building instructions and deployment for the projects, and they will need to work. If they don't work, they will have to deduct points. To let you know a little bit of what this is about, when we did the lab X with Vue, I think I had a little bit of instructions on how to build a deployable package. And this should do it with simply calling the npm run build command. So it's not more complicated than that, but we'll expect that those commands will work. If you're not using, if you're using a different framework, and that's your choice, then if the instruction for building are different, you'll need to provide them. Again, the framework needs to be a JavaScript framework. So if you want to use Django, that's not going to cut it. And the go-to framework is Vue. But if you want to use anything else, React, Angular, or any other, you're welcome to do so. That's a good learning opportunity. I was actually looking at Vue 3 with Vite. And so if you're interested in using that, I can definitely give you an, because I think it's even easier than the Vue 2 once you get into it. Vue 2, you do have the lab X to work with, so that's something to consider. You're going to have from now till to turn in the demos. So I'll ask for, obviously, for the presentation. That's going to be the last day of class. The rest we can, sorry, the last day in which we have class. That I think is the week right after Thanksgiving. But then for the rest, we can wait till the last day of class for the semester. So make sure that you go and look at your timeline and schedule accordingly. The last piece is the video. So this is basically a mashup of the final presentation with maybe some of the more lengthy explanation that you put in the paper in the form of a video that is 5 minutes, and there are readmes for each one of these pieces, including a rubric that we're going to look at in a moment. And the video, you'll want to post it in YouTube and make it accessible. So I guess you need to make it public. You can obviously go and see plenty of examples just by Googling from the past years of students who have done the same. So these are other things that we would like to get listed once you're done with everything. Starting with a project summary. So this is basically maybe a 250 words or so summary of the project. That could be directly what you put in the abstract of the paper that explains what the project is about, what is it, what is original about it, and so on. The contributions, so these are basically by team member. So here I've listed Tommy Georgian, that is the only person who is working in this project. Okay, so the link is the email. So you'll want to update those, and for each item, so for the presentation, if the Tommy Georgian did a couple of slides, you would list them there. If he did anything else, such as set up the presentation, proposal, and so on, then you would list it in there as well. If Tommy Georgian did some research to find out which data are available, then that's another item that would go there. So this, I think you can already start filling because you've done the work. Yeah, I started giving some feedback. I'm sorry that I didn't finish all the groups, but if you have feedback, please go and follow through. And if there are items that relate to the contributions here, you may want to list them as well. The final presentation here is about who did what again. So it's going to be again with SOSI. So some folks will need to go and find pictures that are useful. So that is one task. So you can, if you do that, then you can list it. If you did the transcription, you can list it. If you wrote some of the text for the slides, then you can list it there, and so on. So same thing for the demo, and here I'd like to stress the point that here we have one student, that is Tommy Jordan, that is doing everything. That should be the norm, meaning that the expectation is that every member contributes to every piece, more or less, but at least a little bit. So I understand that for the video that I didn't put in here, that should be listed actually, so you can add it. It's probably most practical that there is one person that is going to do the voiceover and the recording, but then somebody else can go and write the scenario, and somebody else can go and review the scenario and make suggestions. Okay, so all those are things that we want to see listed there, and we want to see every single member contributing at least something to any of the parts. And for the demo, it needs to be substantial. It means that if you have 20 charts in there that you have created, and we have 4 team members and one is doing one chart, that's not going to be enough. It needs to be fair to everybody. So make sure that you split the work. For putting in the charts into the framework and doing the work of that is required for the framework, if you say are using React and you have only one person who is really good at that, it's okay to have that person take the lead in terms of setting it up and so on. But the expectation is that the others are going to help out in some way. So that might include making sure that the framework is working correctly. So there needs somebody who needs to do some QA. making sure that the build command works, documenting the build command. So all those are things that anybody can do. And so somebody should pick those up if you only rely on one person to do that part. And again, it's not an excuse because you know how to set up a framework, not to have done anything else in the demo, meaning that, oh, I'm just doing the framework, nobody else is helping me, and so I won't do any chart in there. Okay. Right. So because even if that's the case, these frameworks are just placeholders. What is complicated is to set them up. Once you have set them up, then anybody who knows a bit of JavaScript can go and do a little piece on it, right? So you can you can set up add a chart, connect a chart to another chart, add some interaction, whatever. You can always do some little feature, provided that you have some understanding of the framework that is being used and some simple instructions. So I did show you that with Vue. So if you don't have a specialist in your team, then you would use Vue, and there obviously it's going to be on all hands on deck. If we talk about creating a dashboard with React, and you have only one person who knows React, well, that person, whenever you make that decision to go with React, needs to commit to be able to explain how to do some of the things, such as adding charts to the others, so that the others can get something done to help. And the person who is committing has also some extra time to provide help with creating the visualization, because here is the goal. So hopefully I've been clear on that. So now the grade is going to be a group grade, but we're going to look into the fact that the individual contributions need to be fair. Because I think it's only fair that in a group work that everybody is contributing. And if you have somebody who is not doing much and not doing any effort, then it's unfair that the group should be penalized as a whole. So here below we have a checklist that you can use for the visualization that are needed, meaning that they are required for the demonstration. That is the dashboard that you're going to build. So these include a responsive chart. So go back again to AX if you're not sure what that means. A chart that is interactive. Again, we did that in several labs. A chart that has animated transitions. A chart that is a layout. So all of these are WSD free, as you can see, and they need to be WSD free. So and yeah, so we had in the past people that you know, would go and use some other machinery and just put a chart in there, and then we'll go and look the code up to make sure that it's done with the free. Okay. The layout, I think we did several layouts in one of the homeworks. So don't go and pick the one that we did. just because you did it already. What we want here is that you pick something that makes sense for the data that you have, and also that it is well integrated. So whatever is required here, it doesn't mean that you go in the homework and you pick a chart that we did already, which is encouraged, with the caveat that you do need to integrate it, which means that the look and feel needs to be the same across the dashboard, and I think we explained why that is useful. And then it needs to work well in the page, right? So and the layout of the page needs to work well with the charts. So so all those things, I think you're aware of those. A map with D3. So I put this in as comments in a lot of the proposals that I've looked at. So you need to have some data that are spatial in nature, so that you can do a map. Because maps are important. A lot of the data are location dependent, and it's important that you know to show those type of data on a map. And then a map box map. Ideally, those would be different maps. The reason is that with Mapbox, it's one type of application. It's a map where you can navigate to certain places and create layers that you can add to the map. With D3, it's mostly static maps, right? So those are not the Sleepy maps. So it's mostly for displaying static information on top of the map for one particular location, which can be the entire planet, but that depends obviously of the data. So you can see some example of these in the past projects. People have done projects that I can think of that were compelling. So we had one on World Soccer, where the World Cup, where they were showing the provenance of for different teams of players. So there's one, another one that did also in soccer. They did the European leagues, and I don't remember if it did more than that, but at least the European leagues, and then you would be able to see for each team where the players are coming from, and they used Mapbox for that, and then they had a world map with D3 for showing other related information. There was a project on mobility in Los Angeles that was very compelling, also using Mapbox, that was to try to understand the patterns for the shareable bikes that Metro is as in LA, in terms of how many are at which station, and try to explain why a certain station would have many bikes and others would not, based on local patterns, such as how many businesses are around, how easy is it to access from the metro lines, and so on. Yeah, and so all those thematic maps, I think that you can go and look at some examples, and definitely you should look for the projects, not just at examples of what people have done for the same topic, that is a must, but you should also go and look for based on forms. Say, oh, how do people are using maps in these other domains? And is there anything cool about that that I can use in my project? So here is just a list of those required that maps to the website that you're going to build. So here I give you an example. So I'm saying for the home page, I'm using visualization that is my main map that I build with D3 and TopoJSON. And this is matching this label here for the checklist of required visualization. That is the map. That is the D3 map, actually. So you'll want for each one of those at least to put in a page. And if you have extra, you're welcome to list them there. Obviously, you can put the requirement label as an A. And that is useful information to us to see how many charts you've actually created. And yeah. Summary table of visualization forms used. So yeah, this is a little bit redundant. So yeah, just maybe just keep, don't do what I said a moment ago. Just keep this table of visualization used by page for the required ones. And here you can list everything. And these are just, this is a frequency table. So we're just by type. I think that that's going to be enough. Yeah. So you can go. I mean, this it's just an example, but you can go as detailed as you want. If you want to say how many pie charts you have, that's good too. I let you know enough of visualization now to be able to come up with meaningful categories for this. So this is all in the README, and this is your first place to go. Let me close it, and then we're going to look at the assignment. Okay. All right. So nothing new here. This is basically the 4 things that are expected: the demonstration, presentation, the paper, and the video. So there is one part that has to do with development, and so this is directly related to the repository, and it's basically the same thing that we've been doing with the repos until now. So whenever you're implementing something, don't make it too big of a commit. We'll want to see, obviously, that everybody is committing in the repository, being for adding main features as for just fixing problems. Now I think that Git, yeah, the Bitbucket used to have an issue. I think you can still do it with Jira, but yeah, it's up to you how you want to QA the projects, and but it's an important part. So don't we're going to, I think we talked about that already. Start by prototyping, by designing. So you can use, there are many tools that are useful for designing. Don't start trying to create pages and make them beautiful after, because that usually leads to a catastrophe. If you don't know Figma, just make sure that one of the team members knows Figma or a tool that is similar. Figma. Yes? No? No, you don't know Figma. Okay, I can show you that. Figma. Oop. Okay, so that's an interface for designing interfaces. Yeah. So you can go look in there, and they have all sorts of products templates that you can use for different products. So these are mine. So here you see that we've developed a dashboard for modeling freight. So I'm going to open it up so you see how it looks like. I don't know what this is, so I'm going to click it away. Oh, okay, sorry. Stop share, and I'll share this. Okay, good. Share, here we go. Okay, so I'll go back. You know what, so yeah, so this is online, but you can also get the app that is what is called a progressive web app. Do you know what a progressive web app is? You don't know. Progressive web app is an app that you can use on different devices that is built with JavaScript. And that is basically using the browser capabilities to run your application. So people do it a lot when you need to do a mobile application. Instead of doing an Android version and an iOS version, what you do is that you build a progressive web app with React as a framework that it can be used for that, but there are others. And so then you just say, okay, now I want to build this for iOS or for Android or for desktop. And so Figma here, you see their web interface, and if you want, I can show you. I'm going to stop sharing then. Okay, here we go. Share screen. Okay. So this is the progressive web app, and as you can see, it just looks more or less the same. It is because this is just a regular application that they've built with some type of a framework here, and that uses everything that is available with the browser. So I wanted to show you some of the things we did with it. Maybe so. This is one that we recently. That is an interface to try to understand freight pattern, that is patterns of trucks in Los Angeles from sensor data. And so as you can see, you have toolkits that come with this. So this one actually I think was more or less done from scratch, maybe aside from the load button, but you can if you Google Figma and Bootstrap, you'll have something to start with where you have the buttons already ready, and you can just use it to prototype it. So here we're actually thinking to do a progressive web app, so we can just go and load data that is on the device. We ended up just running it with a server, and then these are, you see, as you can see here, they're in public. Yeah. So okay. And here this one, I think that they have some interaction that I didn't do it. The student that did it knows probably how to run it. But the idea here is that you want to have an understanding of, okay, I'm going to click on this row, what happens on the map, right? Because this is a certain truck, so I probably will want to see the pass for the truck. I want to have some information about when it started, when it got there, and so on, right? And so then here, this is a placeholder for 8map, because I guess that what we wanted to do here is show a 8map of the highways, color coded based on truck traffic. Because here what we see is the traffic that is available. So do use some of these tools to not just say, okay, I'm going to put my graphics here and there, but think in terms of what is the information that you want to make available and how people are going to interact with it. Yeah. So there is the functional part that you need to try to understand. Now this is for a truck simulation, so it's a little bit. I don't know if how do I get out of here now. No, okay. Okay, there you can change the name. Okay, I'm going to quit it. Hopefully, it's going to take us back to. Okay. Yeah, I'm sure there is a more graceful way to do this, but I think you get the point. Let me see if there is another one that is useful. I think this one might be a good one. Yeah, so this is an app that we've built also for UAC. That now it's called actually Crowd Map. So here we're using Wi-Fi connections to try to understand how many people are in a given access point location. So obviously this is useful with COVID to understand if policies are followed. So if the university says, you know, this classroom, they need to be at a certain capacity, then you're able to go and look at that through the Wi-Fi, because most of what we do is with connected devices. Yeah, so this is an early mock-up. We actually implemented all of this and more because I don't see it here. Yeah, so now you actually much more views than what you have here, but this was kind of the bare minimum that we wanted to do. We actually have added aggregate plots here so that you can see the trends over time. And these are aggregated over the building areas, and we have filters so that you can look at them in context. Here we did a dot map with a proportional symbol that tells you that is sized to the number of people that are connected to that access point, with the floor map of the building. And we actually have this for all the buildings in USC. So yeah, so this is far. I mean, if you want, I can show you the finished product one of these days. But the idea is that this gave us the minimum viable product that we wanted to build, and then it allowed us us also to think in terms of how do we show this information based on the data that we have. Because the access point, we only add their location relative to this floor maps. We didn't have it relative to the main map here that is done with Mapbox. Otherwise, we could have done a heat map and all sorts of things here, right? So yeah, so it's really important that you design things, but thinking about the functionality and the interactivity of it as you do. Okay, so let me go back to this. Okay. I think it's this one. No. Okay. Okay. Now it should be good, hopefully. Okay. So yeah. So I can kind of diverge a little bit here, but yeah, good development also means that you're thinking about what you're doing. So it's not necessarily something that we'll be able to validate here. But you know, if you use Figma, make sure that you explain what you did with it in the paper and how it helps you to develop your project, right? So here is more about the mechanics, what tools you used, making sure that you hit most of the requirements, so that you can see that you need to use Node, D3, Bootstrap. So you have put Bootstrap. If you want to use something else than Bootstrap that is equivalent, there are several. That's fine too. Material design is a good choice. To just make sure that you understand what it means and how you use it. But that's what I've shown in the LabX. Okay, so the demo, you have again here the requirements. They should be the same that you saw previously that were to be listed in the README. Yeah, so here you see a little bit more detail for the layout. That what we consider a layout is not just a line chart or something that is created with a D3 generator. It needs to be an actual layout. So a pie chart would qualify, but again, don't just go and pick the pie chart because we did it and now you know how to do it and it's easy. Pick something that works for your data and the information that you want to show. Okay, and you can, so your layout can also be interactive, right? So here it's really the bare minimum, right? So don't shoot for, oh, this, I'm going to create one chart that is interactive, one chart that is responsive, and one layout. Because remember, form follows function, okay? So what is important is what is the data and the information that you want to display. Then you pick the form. Don't pick the form because I've listed it here. Whatever form that you're going to pick, you can have multiple that are interactive, multiple that are responsive, multiple that are D3 charts with animated transitions. You can name it, right? As long as it makes sense and it's useful for your data, then you have a good way to, you have a good reason to put it in. Which doesn't mean that you need to make it simple because your data are too simple and oh, I cannot do any of this. Because yeah, I mean others have done it before, so trust me, you'll find a way to either complementing your data set or adding some questions that you want to have people answer visually, so that you can actually make use of interactivity and animation. So here the website works well. It means that when we look at it, there are no obvious hiccups, and that includes the charts, obviously. And also depending on what we do for the deployment, that might include that. Yeah, so here I guess I had this highlighted and I left it in. We can probably just remove it. Oh, I think you can just do like this. All right, so this I already said it, and so I won't go through it again. Here you have the exact format that is asked, that follows the Pecha Kucha. I'm asking that you put some information on the first slide, and I'm going to show you that there is already a template that does this. And then we can do a lab on it. So you shouldn't have a problem really doing these things. So these are suggestions on what to say for the presentation. So make sure that you explain who did what. You don't need to go as much in detail as you would do with the README, where you want to list, you can be exhaustive. But here you want at least to say in broad strokes what everybody contributed to, and highlight so some of the things that, you know, say if somebody has done something specific that you find important for the project, you should use that, the presentation, to highlight it. Yeah, the rest is more or less what I was asking for the in the proposals. Here, obviously, it's going to be finalized, so you know exactly which tools you've been using and for what, so you can explain that. And you'll probably have more time to do a little bit of research and see what others have done in the same or different domain, and what you would do to improve your project if you had more time. So the paper also, we're going to do a lab. So here you have the format. I think I'm already providing the file that you can use for that. This is only 5 pages long. So don't do like my son that is doing college application and is waiting the last second to get started. 5 pages is not much to write, especially if you add a couple of figures and the bibliography. But you want to make it quality 5 pages. So you usually a good way to go about this is to start writing an outline. So you can just do bullet points for what you need to explain, and then find an actual outline, meaning titles and subtitles for the sections that make sense. And then you actually format this into paragraphs, and if somebody else read what you write, so things improve along the way. So again, we're going to do a little bit of a lab on that. That will include getting started with LaTeX, which is not much really if you use this tool here that we're going to see. The video is also 5 minutes or less. Now these are really a hard stop because we had people do 10 minutes videos ranting about things, and that's not useful because we need to spend 10 minutes to look at a video to find the same information that we would get from a 5-minute video, and that's not helping. So for this also, you'll want to think about it, not just say, okay, we're done, let's do the video. You want to have start doing a scenario. You can do a PowerPoint if you want, where you say what we're going to see on screen and what you're going to see, what you're going to say about it. And once you're clear about that, then it's just a question of producing it. Okay. All right. So this is for the assignment. I'm going to close. Yeah, save it. It's fine. Yeah, I can actually, if you, yeah, I'll push it. So in case people didn't get these changes. Okay, fix it, cosmetics. So if you didn't clone the repository yet, then at least you have these. All right, so I'll go briefly. What time is it? 57. Okay, I'll go briefly through the different pieces here. But again, we'll have a lab on that, so you don't have to worry too much. So demo is where you want to put your code. Okay, so I've put here that you should provide the build instructions to generate the app. So that's really the minimum. And these need to be idiot proof, please, because we don't want to get crazy with it. And yeah, let's do that until we decide if we want to deploy it. If you want to deploy it, the advantage of deploying it is that then you have a link that you can point to and that you can put in your resume. So that's the main reason why we did it in the past. So yeah, students complain because it's complicated to deploy it. At least some students. But at the end, I think that they were happy to have that to show as a portfolio. So yeah, just let me know what you want to do, and we can try to facilitate it. Otherwise, if it's just for the grade, I think that the easiest is that we do, you provide, you make sure that the npm run build works, and then that's what we're going to test to make sure that you're able to get to that steps, but not actually put it in a web server. Yeah, so let me know. I have a couple of machines that I can set up for that. Yeah, the main thing is to give you access and so on. So one option is maybe that we have a team that volunteers that wants to actually do the deployments. So that's an option, and then we create just a few accounts and we make sure that these things get deployed. If you don't want to go through the hassle of of learning hardcore Unix, which is always useful, but not everybody is into that. I can understand that. Paper. So here there are more details, and we're going to do over this during the lab with information on basic overleaf to get started, on the template to use, and on how to set up the bibliography and so on. And here you have the actual an outline that if you have no idea on how to get started, that can help you get going with the paper. And you can see here that I basically, this is LaTeX, but it's just bullet points. I've just started creating bullet points for the introduction. And if you use the template, you already have the sections that have to do with the abstract and the references. So that you just cut and paste this in, and you are ready to go. But we will do this in time. The presentation also, I'll show you how to use SOSI. It's not too complicated, and you have one presentation that is already here that is set up to go. So you basically just have to find the right pictures and understand what to say. And the video is just yeah, a transcript. Just in case we want to go and look up some of the information. So again, you don't need to, in the transcript, I would do it per slide. So here is the team member, I didn't put it, but I would say slide one, sorry, slide one. It's not slide one, is I don't know, maybe the first segment, right? That is the, I don't know, introduction. Maybe you can do I don't know, from 0 to 5 minutes. No, it's not 5 minutes because the whole thing. So maybe to 0 to 30 seconds. 30 seconds, and then you put this as a title and say, okay, you can do a bullet points, or you can just copy and paste the exact words that you're going to use. So when you produce the video, you just go and read this. Yeah. All right. So again, we'll do a lab on this hopefully next week. But yeah, and hopefully next week also we can give you some feedback on the project. But you can start using these. So for those who were not here at the start, I've posted in Slack the link so that you can go and use it. Okay, so we'll do a quick break, and then if there are questions on the assignment 9, that is the last one, we can go quickly about it and start with the lecture 10. Right, give me a break for a few minutes, and then we can restart. Okay, so I'll restart. So a couple of things. So one is the A9. So I don't know if there are questions. I don't see many people online, so I guess folks are going to look at the lecture later on. I've been seeing quite a bit of requests. I think this is the time when I saw the most requests for to push forward the deadline. So knowing that we kind of started this on Monday, I think it's fair to do that. Let's push it to next Monday. But do use the time for the office hours. If you have a bit of time to just go over the things that you have trouble with. So yeah, I had a few people yesterday during the office hours, but not nearly as many as I see. So hopefully you don't have that many questions, but do use the office hours from me or the TAs to move quickly on the assignment. Now, this said, if you have questions, this is also a good time to ask. So I don't know if the folks that are online, if you have questions, if you want to post in the chat, or we can try to do an experiment and see if you can ask, if you want to ask your question, you can unmute yourself now and ask the question. Nobody has any question on the A9? No? Okay. All right, so if there are no questions with A9, then what I suggest we do is that I get started with the next lecture. We'll if we don't finish it, I don't think that we're going to finish it today, but yeah, we'll adjust the time for the quizzes. So we're going to have still quizzes for the lectures, but no assignment after this one. All right, so yeah, I didn't have time to post the PDF. I'll do it as soon as we're done. So let me go back to Chrome. Yeah. Okay. So here I had prepared in case you wanted to go over some of these. Yeah. But I think maybe aside from the last one, but no, I think that now you know enough to be able to understand what is going on. Actually, yeah, maybe I can take the time just to do the Altair one. That are the last two. Because I see that I didn't even open the last one here. Yeah, did I go through this? Or probably not, huh? The A8. Did I do it last time? Altair? No? If you don't remember, it's probably that I didn't do it. Okay, so I'll go through these two quickly so that at least you know what, if you have questions, you can ask them. Okay, so I think we started and I say a few words that Altair is basically a front end written in Python to Vega and Vega Lite. And the way it's rendered, as you can see here, is using I think it's called the Vega render that we used at some point. that you can put in a web page to render from Vega specification. So usually, if you remember the Vega, what we did is that we wrote Vega Lite, that is the less verbose form of the XML that describes the chart. And then the tool here, what it does is that it converts it into Vega by adding all the defaults, and eventually this is what you get here. And this you see if you go to the Vega editor. It is coming up here. Okay. Okay. Now okay, yeah. So there you see so this is the Vega Lite spec. That is the same. Yeah. So here we have one. This is the data. So the data is basically more or less in clear there. Added as a data set, and then because we have here one entry per one row per point, that's quite a bit long. And then there are obviously the plot specifications. And here we can see the compiled Vega that comes from the Vega Lite specification. So this one is extra verbose. Yeah, so here you can obviously just go and change the specification to change the chart. I think we did that in the past. And then you can export in different ways, including as a Vega Lite or compiled Vega here with JSON that you can then use to do what is being done in the notebook here to realize the chart with the Vega render. So what it is that it's a grammar that is a little bit different than obviously the ggplot2, but it's similar in ways. So the ggplot here here you see that they're using the chaining syntax as opposed to use the plus in ggplot. There are no real defaults. The defaults part is really the alt chart, and then you say which chart you want to realize, which data set you want to use, and this is the equivalent of the geom point because we're doing a scatter plot. And this part here that says encode is the equivalent of the aesthetic encodings with the AES. And you can see that it does pretty much the same syntax where we say how we want to map, where these labels are defined based on the data variables. So here we see the rendering of this car's data frame, and you see that the variables names are the same here that are mapped to the X and Y axis. So if you understand ggplot2, you should be able to understand this, with the caveat that things are a little bit different. Mostly because of the chaining syntax, but yeah, it's mostly because of that. Okay, so the bar chart, I'm just going to re-execute this to make sure that is refreshed. All right. Okay, so here we're just setting the opacity. So this is semi-transparent, and we've seen that that's a good way to deal with overplotting. And now we're going to look at doing a bar chart. So this one is really a basic bar chart with a default that doesn't size the chart in any spatial way. So these are just the defaults. And most cases, not what you like to see. The vertical labels is usually a bad idea. So you can try to switch the axis, and so you get an horizontal bar chart, or you can customize it so that you can turn the labels around and or resize the chart so that you put enough space so the labels can be horizontal. But this is the default that you get. And it's mostly because that's a default that makes sense in general, but for bar chart, I don't think that's the best way to show it. So whenever you want to set the bars, same things that with ggplot2, you can either do it with data frame, and then you use the same type of marks here, the mark bar, and obviously this is the same thing that comes out. And here we're just resizing it so that it looks better. So you see that in terms of the stats, we're basically not doing anything different. So the mark bar assumes that it's getting counts out of what is needed. And otherwise you need to compute it. So here we did what I said a moment ago, that is to resize the chart so that we can set the labels horizontal. The box plot is shown here, and it is obviously the same thing. It's using the mark box plot. In ggplot2, it's the geom box plot, but that's otherwise similar. You'll note also that in ggplot you can you don't need to use the label, but you can directly reference the variable in the data frame in the AES with the AES function. Here you need to put the label. I don't think this is going to work. It doesn't. Okay. So I think that's a question of how the data frame are mapped here that makes this a little bit different, but yeah, just something to have in mind. Histogram is here. So the histogram, you see that it uses a bar chart, and then you need to set binning true, the bin parameter, on the encoding for the X variable, which you can do this way. That's an alternative way of setting up parameters. Because when you just call the X equal something or Y equal something, you basically can just set the variable that is being used. But in this way, you can, you see that you have parameters here that can be, this is probably set up to, no, it's not, okay. So they're positional. So this function allows you to configure basically the X-axis. And the first parameter needs to be the variable in the data frame. So you can obviously access the help and either online or through Python for Altair to see that if this is set to false, is the default, then you get bars of counts, which is not what you're expecting. Yeah, and because we're doing this bin that is actually doing the binning, we know that we're asking for an histogram, and therefore the bars are close to one another. Okay, so the line chart, not much else to look at. It's just I did a simple data frame with X and Y's for the points, and then we just set them up with a Markov line to draw the chart. And here is the simple example of how you can customize it. I think we actually got to this point. Now, I don't know if I demonstrated this, but here we've added a couple of things that make the chart a little bit nicer. I'm going to make it a little bit bigger. Let's say 600 by 580. Okay. And you see that this one is interactive. I can drag and I can zoom. So this is added through this interactive at the end. The sizing and title are set with the dot properties. And here we're adding an encoding for the color. So you see, and this is again similar, very similar to what you would do with ggplot2, where you would set the encoding for X, for Y, and for color to one of the variables. And you see that here we're using the long form because we want to configure it. And in this particular example, we're also configuring the title of the axis. So this is a parameter. And this is another one where we can set the scale, not to include the 0 because we don't want to include the 0 here. So that the data start wherever, and I probably need to make it smaller so that we can see it, but 400 to 100. Yeah, so you see that the scale doesn't start at 0, it starts at 5 and 40. And it's because we've configured it with the 0 false. So all of those you can access through the scale object in ggplot2. If you remember, the scale is also part of the grammar, but is not usually used. It's mostly used internally. And what you do if you want to configure where the graphic starts is that you have this the range that you can set up with I think min and max, if I remember well. So same thing here as for the axis. You have this dedicated function that you can go and look up in the documentation, but the basic is that it gives you the ability to set up here the title. And obviously you can play around with the axis with the rest of the visual properties, the labels, the number of labels, and so on through that. The other thing that here is interactive and useful is to be able to see the data. And this is done here with a tooltip, where this tooltip you can just set up. Let me maybe create a new. Here we're going to look at these cars. Okay, so say that we want also to see the name of the car, so we can just add it here. And then this should show up in the tooltip as you would expect. So it's not more complicated than that. And when you're doing data exploration, if you want to see which one are the outliers and so on, then that is something that is quite handy to have in terms of interactivity. that yeah, 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 the matplotlib, I don't think that they have that available, at least not in this easy form to use. Maybe Panda has it, but I don't think so. All right, so the exercises are just implementation of similar plots that what you've seen up there and in the others. So I'll finish up with this one that is Altair maps. So yeah, don't ask me why again. Maybe this way is better. Okay, so this one is maybe the most tricky one to implement. So maybe I'll go for it quickly. Because now that we know how to do these things in D3, we can actually understand this code. So you see, we're using these Vega data sets, and from it we're getting this airports.url. So we can go and look at that just to have an understanding of what it is. Maybe just print this. We should be able to see it. Okay, so the file is there. Whoops. Airports, here we are. Open, yeah, okay. I need to show you this one. Just give me a second. I'm formatting it on screen. Here, there we go. Okay, so it's just a CSV you can see with some type of identifier, and those are standard identifier for the airports. Then you have the name of the airport, the city, state, country, and then you have the lat-long coordinates. Okay. So obviously, to put this in a map, you know that you need to project it, right? And the other thing that we'll need is the other piece. Oops. So let's go. Let me go back. To Chrome here. Okay. The other thing that we need is the GeoJSON for the map. And this is coming from here. You see that so the alt is I didn't mention it, but I should have. So this is the entry point for the Altair library, right? So you've seen that the axes are called alt.doc, .x, and so on. So this is a functionality that allows you to get to some TopoJSON feature based on this data. So now that you know what TopoJSON and GeoJSONs are, you can probably understand that this is some TopoJSON data, and this function all it's doing is what you're doing with D3 TopoJSON dot features. That is going to get the features out of this map, and here we need to say which features we want to decode from the map, and it's the states, right? So we can go also and look at this, but at this point, I guess what we have is the GeoJSON features. Oh, sorry. Okay. Now you see this is coming from the data set, but it's a copy of the US 10, where 10M means 1 meter is 10 million meters, or and this is coming from the US Atlas probably. that you've used in A8. Is that the right one? Yeah, okay, here it is. And so you can see that here we have topo.json because we see that we have arcs. Okay. So obviously those we need to translate into into GeoJSON, and this is what this function is setting up. And then we can start saying that we want a chart with this data. And the mark this time is going to be a GeoShape. And the GeoShape, basically what it does is that is going to take the GeoJSON features and create a GeoShape mark, similar to XY and the point mark, creating a point. You know that the two properties in SVG that you can associate with a path are the fill and stroke, so hence those that are there. And this is to size it. Now, this doesn't include the projection because this data is in and similar to the airports. So the airports is the second part here. Needs to be projected, and so yeah. So we still need to do the projection, which is done with this project function. So this is the grammar that is extended to maps. I think that they did the same. You can do similar things in ggplot2, and it's kind of in natural extension, because all this grammar, they're prototyped to do graphics, simple graphics, statistical graphics, but not necessarily maps. And so here you see that they did it in a certain way with this mark GeoShape, but you still need to make things work because the data needs to be projected in some way. It's not just a question of scaling it. In a regular plot, you get away with it because it's just about sizing, so that if you give me a size of a scatter plot, I can find a default way to put all the points in the display, and then you need to deal with overplotting. If you give me the size for a map, it's not that simple, because I still need to take the data in lat long and put them in the coordinate system. And I have different ways of doing that. If you don't tell me, I cannot do it. So that's why the project is essential here. And what we're using is, because this is a map of the US, so you know that for doing a correlation of proportional symbol map, then the Albers USA is a good projection. So this is the composite Albers projection that we've seen in A8. Okay. Okay. So here the last thing that we're doing is dealing with the airport's data. And as you can see, we don't want to put every individual airport here, but we want to get an aggregate. So you could do this with a data frame and just then do a proportional symbol for once you've computed the aggregate, but Vega Altair gives you this transform aggregate function that allows you to act on the data. So here what we're doing is that we're getting the mean latitude and mean longitude for all the airports by state. And that is because we're doing the group by. So this is obviously possible because it's implemented in the grammar, and you've seen that ggplot does something similar, but there is so much that they allow you, but because this is an operation that you often need to do, it's implemented there. So you don't need to go and implement it outside of it. And then you see that we encode the circles as the symbol here as a circle that is sized to the size of the count. Now here the title is number of airport that shows up in the legend. So that's the title that is used in the legend based on the size encoding, because the legend refers to let the user understand, read the data. So if you have an axis that is an x-axis, then the alt x title is going to be the title of the axis with the proportional symbols where you're encoding the color, the size. Then the title is obviously the title of the legend. Okay, so that's the logic behind it. As you can see, also I put a tooltip for this mark circle to show the state and the count. So when we mouse over it, you can see it. Now these are some of the examples that you can go and get from the gallery in Altair website. So I really encourage you to go and look at those if you want to learn more. Choropleth is basically the same ideas. And here we're obviously just coloring the areas. So you see we're using the same data set, we're using the same projection. So here this is positional, so we in the previous one we didn't set it. Where is it? It's here. We didn't have to write the type. And that is because probably there are other arguments to this project function that we can use. We're doing the sizing in the same way. And here we're doing this conflation of the data with the GeoJSON features that we had to do when we did the choropleth in D3, right? When we used the map, and you remember that we had to use the map for this. So here we're doing a lookup map in the same way with this alt.lookup data that is a lookup function from Altair that allows you to set up a lookup so that when you show the data, you can show it based on the value of in the lookup table. So here the lookup data is set up with one array of values, and here we're just using one, that is rate, and the same rate here is the one that we're encoding in the color, right? Does that make sense? So again, these are part of the grammar, and you could do them with a data frame, even though here it's probably more complicated than we think, using an external data frame. So these are kind of extensions to the grammar and functions that are useful in different contexts. That's why they're added there. But if you don't do this, then you probably need to create a data frame, and then I don't know if you can actually go and configure the GeoShape to tell it to use that particular information. No, probably you can. Yeah, probably you can if you just if you create a data frame where the counties have the rate added, then you should be able to add it to the GeoShapes, which basically means encoding the data in the counties. Doing it with a separate data frame, not sure. I haven't seen it done. Maybe there is a way, but this is what is provided. And the exercises are a little bit more the same. That they're not very much more complicated, but yeah, if you have questions, you can go and ask in Slack, and I'll try to answer to that. Yeah, we'll do the lecture on Monday. That is on unrelated topic here. So maybe it's best if we just start it on Monday, because now the time is over. So you concentrate on finishing up this homework and the A9, and hopefully you have some time to look at the project, so we start moving on that. All right. Thank you.